Okay, good morning, early birds. Thank you for joining us inside. We know it's lovely outside. My colleague Phil Kay and myself, we really would like to thank for the opportunity to present these two sessions this morning on predictive modeling. And we have two topics prepared for you, two examples, and Phil will present the second example and I will present the first. And I would like to give Phil the chance to introduce himself, and then I will take over and we will start with the first part.
Yeah, sure. Thank you, Volker. So I'm Phil Kay. I'm a chemist by background. Did my PhD in Edinburgh in microwave chemistry. And then I worked in the chemical industry for about 10 years with Fujifilm, which is where I learned about statistical modeling and design of experiments and predictive modeling. I now work for JMP. I'm part of our global technical enablement team, so I work with some of our biggest customers in industry around the world. And I'm also involved with the Royal Society of Chemistry. I chair the process chemistry and technology interest group. So, please come and talk to me and ask me any questions about any of that, anything that we can help you with. And I look forward to presenting the second session of this workshop later, but I'll hand it back to Volker for now.
Thanks, Phil. Okay, yeah, I'm with the global JMP academic team for 12 years now, and based in Germany. Background is electrical engineering and traveling around over Europe, visiting universities, helping professors and also students, researchers to use our software and our resources. And especially in the UK, we work with many universities, like Oxford, Cambridge is starting, so I will provide more details on this later. Imperial, different, Manchester, different sites using JMP. I would like to keep the introduction really short and come to the first example as soon as possible. So the idea is to invite you to follow along, and to experience what we are talking about yourself. We won't use any slides during our sessions. It's PowerPoint free. But if you can open this file we shared yesterday with you, then you will be all set. That means you have JMP installed on your computer because you need JMP for this. It's a so-called JMP journal. Who has access to this on the computer right now? Cool. So most of you, that's good to see. We prepared some data sets and also some results already you can explore from this journal. So it's all in there. It's one piece to navigate, and so it should make it easy to see how it works. But the focus this morning is not about how to do things in our software. It's not the how-to. It's really more the statistical thinking, the user's point of view, why we are doing this, and what are the results telling us. Maybe we get some answers, and then we get another question. So it will be really progressive, step by step. JMP works more, interactive, and you make on-the-fly decisions during your analytical journey. We will see this together, so I don't want to talk about this any longer. Yesterday I heard several times that you really appreciate that this event is bridging between the two communities, machine learning, AI, and biochemical engineering. And that's also what we like to do. We also like to build bridges, especially between our industry users and academic users. And I don't want to spend a lot of time on this, but just to mention that JMP is a standard package in industry for analytics. And if you look at our homepage and then why JMP customers, you can look for chemical references, also biotech or pharma and others. And then you can see maybe some well-known names, and you can read about the problems and the solutions they found using our software. So that's maybe a nice read you can find there. And especially in chemistry, biotech, the main applications these type of customers use in our software are DOE, designing experiments, and also modeling, predictive modeling, machine learning. These are really the core applications. And this is another website you could also use and browse for yourself if you are interested to see what JMP offers to walk from data to insights. Yeah? And on that journey, it's not predefined. It's step by step and progressive, and then you combine capabilities from all these applications here. And if you're interested to learn more about some of these applications, you can look into them, and then you can see some use cases and key capabilities which are provided. So these are maybe some pointers to provide. And then the software, and if you have a Mac like me, then you will find the JMP Starter on the window menu. If you have Windows, then you find the JMP Starter on the view menu. That's the most complicated thing today. So it's called the JMP Starter, and if you find it, you can also see an overview about the capabilities here. So if you're interested in experiments, designing experiments, so you see the optimal design tools, definitive screening, classical designs, of course, and also some special purpose designs. So as I said, this is a core application in science and engineering and also other fields. But there are also modeling tools, many modeling tools, of course, the family of linear models you can see here. Yeah, also specialized models like curve fitting, nonlinear modeling, and functional data analysis. So this provides techniques for functional machine learning or functional DOE. Yeah, but that's a different story, so we won't touch today. Yesterday, there was also somebody talking about the performance of Gaussian process models you also find here. And then under predictive modeling, these are more the machine learning tools, and also some meta tools, so which help you to find the best model. And we will also see this in action, the model screening, in a few minutes. So that's just an overview, and now let's start to look into the first example. So we picked two examples, two case studies for the presentation today, our two sessions. The first example uses a larger data set. It's not really big data, but a few thousands of measurements on a chemical product, making a chemical product. And this data set, which is also linked into this journal, this data set has been found online. It's taken from a publication from the Science Journal, as far as I know. Phil found it and also developed a blog post telling the story about this, and this can be found in our community under blog posts, and this is the blog post also providing and explaining the data and the context of this example. So it's from a paper, it's real data, and we will use the data, and if you click on the button recipes, 150 subset, you will get this data set open in our software. If you are stuck, if you have questions, please ask. We can help. But I think it should be pretty straightforward. So what do we have in here? We have yield, which is our outcome. So that's a percentage. Our response we are interested in, we want to predict finally. And this is a subset of 150, and there are more recipes using the ingredients we have in here. So there are 5 ingredients, electrophile, nucleophile, and 3 others. And if you click on this little gray histogram here, so the header also expands, and you get an idea about the values which are in that column. So each column has a variable, presents a variable in our data set, and we have 150 rows, 150 observations in this data set. So it's a small subset of the whole data, and if you calculate how many combinations we could have, so we have 4 levels here, 3 levels here, and then maybe these are 13 or even more levels on that predictor. So multiplying the levels of these categorical factors gives us over 4,000 possible recipes to build the chemical product, and the yield measures the conversion rate in this case as a percentage. And for this we see a histogram here, and then for later we also already have a split of our data set. So this is for validation purposes, and we have most of our data will be used for training. 113 of our observations, and the other observations, 37, can be used for validation purposes, so to pick the right complexity of a chosen model. So what will we do? We will follow this journey here. So the first step is really what we yes.
Sorry, I just have a question.
Sure.
Could you explain to us what is the format of the data that we should provide in order to get such table accepted by JMP? If we want to use our own data?
Yes. Many options. You can start with CSV raw data. You can start with Excel spreadsheets. You can have other data formats, Minitab, SPSS. You can import from databases. There's a query builder, so to query data from a database. You can load data from internet pages. Many options to get the data into JMP. Yeah.
Just download my data and it will sort everything itself.
It's basically file open, and then you can open all of these file types. And if you choose Excel, for instance, you get an import wizard. Okay. You can preview and configure, and then when you're happy, you say, get it, and then the data will be loaded into a JMP data table. Yeah, many options there, but it should be an easy step. As soon as you have the data in JMP, the first step we recommend is have a look and explore the data. So this could help you to get some ideas, maybe also find some hypotheses you want to prove later on, but you may also see some quality issues, outliers, and so on. So data exploration really makes sense. Then today we will also look into some exploratory modeling. So start with a model to better understand the relationships in our data. And when we feel ready, we will move on to building a predictive model. Also using validation to protect against overfitting. And then we will have a few models at that stage after the third step. But then we may think, what about all the other models which could be used? Is there maybe a better one for our data set? Yeah, I also heard yesterday with a given data set, you should try a pipeline of different models. That's the model screening we will also see as a last step here. So let us start together to explore this data set. I already mentioned we have a continuous response, keep this in mind, and we have 5 categorical predictors, and this little red icon tells you this is nominal, so it's categorical, just nominal data, and yield is a continuous variable, and that really matters, but JMP will automatically produce the right analysis depending on the data types. So graph builder, this here, the first script which is stored there just starts a graphing tool. Yeah, it's more a placeholder here to remind me to use the graph builder to start the exploratory journey. That's the same as opening the graph menu and choose the graph builder platform. And this is a drag and drop tool to visualize your data. So I can drag and drop the yield. So I drag yield and drop it on the y-axis, and we see all the yield data points on one axis. The data are already colored. Green is a better yield. And I can also take a predictor and drop a predictor on the x-axis. Now we look at yield by one predictor, which is categorical, so we see the grouped dot plots. I can also undo this and then take all the predictors. And this time I also press the Shift key because I select them and then I click on the x-axis because I want to have them side by side on the x-axis. And then I can switch the graph elements and maybe look at box plots to have a better overview about the distributions of our data with the standard box plots. And when I'm done, I click done, and the graph is done. The red triangles are the context menus. So here on the top red triangle, on the show submenu, I can also switch the legend off to get some more space. And that could be maybe the graph I'm looking for. Everything is interactive, so I can point at a box plot, and you see the median and the quartiles. I can also point at a data point, and you see the observation and the values. And I can also select some data points, and if I think, oh, these are outliers or errors or bad measurements, I can also now right-click and exclude them, so to exclude them from any further analysis if that's the decision at this point. Every analysis you create in JMP by clicking and drag and drop, you can save, for instance, back to the data table. And that's what's available here. So I already did some analyses and saved them to the data table. So if you click the second green triangle, you see some other graphs. And this one shows yield by one predictor, but we are looking at contour plots and lines connecting the means, the group means. But I can walk through the different predictors. This is a tool switching the columns on the x-axis. So we are still exploring the data and trying to understand the relationships, the patterns, The third one, distribution, that's an analysis tool, the first on the analysis menu, and it has been executed and configured this way. Again, to show you how to get there without any coding. So how to get there, it's just a few steps. So I choose distribution, and then the variable I would like to analyze, it's yield, and I click OK. So that's the typical launch of an analysis platform. Then on the yield red triangle, under histogram options, I choose a horizontal orientation. I collapse the quantiles. I could also remove this section, but I just collapse it for now. And then the last step is on the red triangle, under continuous fit. I fit all the distributions to see what is the best distribution fitting the yield data. And the winner is a normal 3 mixture. And this distribution is also added as a curve. I can also switch the distributions, look at others, but this seems to be the best in this case. And we also see the fitting parameters and the estimates down here. So this is just a distribution of one variable. The next is also a distribution output, but this time we took 6 variables, and now we are looking at them side by side without any statistics below, just the histogram for yield and the bar charts for our categorical predictors. And is this helpful? Yeah, maybe you already see something. Of course, you can see the distributions in all these variables, but the real exploratory value starts when you select some data. And if I select the high yield measurements, so the better observations, the better data points, high yield, then we see these data points. Oops, I clicked again. So let's take these. We see them also highlighted in the data table. So they are also selected everywhere else and in the other distributions. And this tells us, maybe if we want to have a high yield, this electrophile setting is maybe not a good idea. And this setting is also not a good idea. But these are just hints. Of course, a model will take all of them into account altogether and is the superior analysis step later. But it's recommended really to learn from the data and explore the data first before you do any analysis or build any model. A heat map, another way to configure the graph builder. So here we are looking at all the combinations of our 5 ingredients. And the subset are the colored data points. And we can already get some hint so that we see, oh, maybe this is the low yield region here, this combination. Maybe a better spot could be in this area here. A heat map, and again, you can point to any data point and see which observation this is and select them.
Just wondering, so
yeah.
Like the first line of this plot, there's like nucleophile, and on the second line is solid. Is that going to swap them? So suppose.
Sorry.
You see, now it's easy to look at like boronic acids, which work, which don't, because like these are in nice, neatly separated. Is there a way to swap like nucleophile and solid here? So like you can look at the nice bit of DMF, nice bit of nitro.
And swap this one by?
Just swap nucleophile with solid. So like the solid will be on top, the nucleophile will be like the second.
This way, yeah. Right click. So in JMP, you get many options to dig deeper, learn more on the red triangles, the context menu, or the right click. If you remember these two options, then you should be all set. The next step is doing some modeling, and just for exploratory purposes to understand our data and look into some relationships. Standard technique, use a decision tree. So in this case, a continuous output, we will have a regression tree. And I just reproduce the launch of this platform. The platform in JMP is called partition because the decision tree partitions our data. Nothing happened yet because we have no splits done yet. So we have to click on the split button. What will happen? JMP will look for the single predictor which creates the highest difference between the mean yields between two groups, two buckets. Partition all our data into two groups so that they have the highest difference in the mean yield. So the overall mean is this. So how can we really separate them well using which predictor and how to do this? And then the answer is this one. Nucleophile is the first one. And here you see this is the bucket with the low yield data, and this is the high yield data. And this is the highest difference, the best separation we can get.
One question.
Yes.
When you report how these decision trees work, do you report the validation results?
Not yet. So
because decision trees are known to produce
yes.
a lot of
Yeah.
spurious hypotheses. And,
yes.
Yeah.
Yeah, of course, that's the best practice for model building and prediction. Here we are just in the exploratory phase, and we are looking at all the data now. So, but that's a yes, it's dangerous, and it's a good point because we can split and split and split and make the model more and more complex. And as you know, at some point, we will start also to model the noise in our data and not just the underlying signal. So in JMP, you can split until we get 24 splits, and then it stops. Because there's some protection built in to the decision tree, which says we should not get any smaller groups than 5 observations. So 5 is really the minimum group size, and then we cannot split it further. So this protects here from some, maybe even more complex decision trees and overfitting. This is one general protection which is built in. It's not a validation yet. It's just some protection. I can change it to 1 and then continue the splitting. And I close this one and open the next, which is this here, regression tree of yield with 97 splits. Do not use, it's already on the title of this model, because this is an extremely complex model doing all the steps down to really, really small groups with just 1 or 2 observations. Of course, that's too much. And here you see, just looking at the R-square for all our data, it looks good because the R-square goes up and up and up, almost 100%. So we are explaining everything, but that's not what we want if we want to apply the model on new data later. And that's our goal here. And for this overfitted model, we would get this model visualization. This is called a profiler in JMP. And you can look at the profiler for any type of model. So here we have a decision tree, but for any type of model, you can see the settings down here. Yeah, so for these settings on our predictors, the model tells us that we can expect an average yield of 74%. Yeah, and then we see the effect changing one factor. We see the effect on the output, but we also see that the other relationships may change. So this can be seen on the profiler. So that's an overfitted regression tree. And just looking at this plot here, the measured yield for our 150 data points against the predicted yield, this is too good, R squared, close to 100%. But you know it's not the recommended model. That's one option. Another option could be, what about a linear model? Let's use multiple regression and build a linear model. And that's the next green triangle you can try here. And this just tells you, stop. I cannot fit this model. And this is the first output. And we can see how this was built. So I just relaunch the analysis again for this model report. And here you see this is a multiple regression model. It's called fit model in JMP. We have the response, yield, and then we have our 5 predictors, and we have all the interactions for these categorical predictors. So it's just exploding, and so too many degrees of freedom and too many parameters to estimate for this data set. So this just tells us, sorry, I cannot fit it. Can be maybe build a better, a smaller model. How could we start? One option is to think about, what about screening? Can we maybe exclude some of our predictors which are not that important or not that significant? So there's a predictor screening in JMP which gives you directly this outcome here. It uses a random forest analysis behind the scenes, and you directly get this ranking of predictors. And this could maybe tell us, maybe let's forget about solvent and base for now and only build a model using the first 3 ingredients plus their interactions. No curvature in here because categorical variables, but all interactions. And that's this model here. And we see the R squared is lower, so it's a more realistic or reasonable value, close to 70%, not 100 anymore. We see that this model found the main effects plus one interaction being active. And this was already cleaned up because you can simplify a model by removing an effect. And the non-significant interactions were already removed. I undo this to get it back because this interaction is significant. And then we get some diagnostics, and as always, at the end, the profiler. So this is the profiler for the regression model, but after screening, only 3 main effects left, and these are the ones which are in our model, plus the interactions, and because we have interactions, you see relationships changing, like this one, after changing another factor. So that was the exploration so far, and also some exploratory modeling. To build a predictive model, we can use validation. We already have a split in our data set, the validation column, splitting into training and validation data. And this split can be used on any model, also on a decision tree like this one. Again, I can show you how to build this. So this tree was built using the partition platform. So that's the name. We have the response. We have the 5 predictors in here. But we also use the validation split first time for this model. And then what JMP does is splitting again and again and again. The R-square on the training data goes up, and the R-square on the validation data goes down after some point. And then JMP takes the model with the maximum R-square on the validation data set. And that's the model which is behind this profiler. So that's the profiler looking at the controlled model using validation. And this is the ranking of our factors. So that's an validated regression tree, and this is another diagnostic plot for this one. Maybe we can directly look at the validation data set only by filtering, and this would be the plot we could think about and see if this is acceptable. And then the question is, what about other models? So far, we built 3 models. So we see here we have the crazy regression tree with 97 splits, overfit. And we have the validated regression tree, and then we have this carefully selected and with screening the linear model. Again, we can switch here, and we see that nothing is happening on this factor. So we have flat curves. So it's no effect there, and also no effect for these 2 models on base. But the overfitted tree also uses that one, but that's probably not a good idea and not a signal we are modeling there. So we have these 2 modeling techniques, basically, regression tree and a linear model. What about the others, and neural networks? And so there are many other modeling options in JMP. And you can see them under predictive modeling, neural networks, and k-nearest neighbors, support vector machines, and so on. Do we have to try all of them to see if there's maybe a more useful model for our problem? No, it can be done automatically, and that's the model screening. And that's the last step here. So is there maybe a more useful model? And what you do for model screening, this is the output, the result. What you do to start this, I just relaunch this again. So this is the starting point. You say, hey, I want to do model screening. And then you configure your Y, your axis. And I set the validation split here again. If you don't have a validation split in your data set, you can also use k-fold validation, other validation techniques. You can also add interactions and quadratic effects if you like. Yeah, and then you click OK, and then JMP looks into all these different modeling techniques which were checked, and then this is the result. Yeah, a result for the training data. Okay, that's maybe less interesting. We look at the validation data, and the winner on the validation side is a neural boosted model, a boosted neural network. This is the winner, at least looking at maximum R squared. Yeah, so I can sort this maximum R squared. So there's also a root average squared error. And I could also look at that one. So if we take the R square neural boosted, so okay, let's look at this one, at the details. I run this boosted neural network, and then we get the details here again for the validation part of our data. Yeah, and from here, from this model, I can save the model as a formula to use it later to predict on new data. And what I could also do is I could publish the model to a depot. Yeah, and there I can collect multiple modeling formulas, and then from there, as a final step, I can pick the most useful model from this depot, what I collected here, and then export the model as a C code or Python code or using other scoring code languages to deploy the model in another production environment if I want to take it out of JMP. Okay, it's 10 o'clock. Maybe I can steal 5 minutes from Phil at the beginning of the second part to show you the full data set with all the combinations. And we will apply the models then on the full data set and check the prediction performance of our models. And then Phil will continue with the second topic. 10 o'clock, I think it's time for coffee now. See you later. And if you have any questions, you can also contact us during the break and, of course, after the 2 sessions again. Coffee time. Thanks.